Okay, good afternoon, pilot teachers, and good afternoon, students. Thank you. Sit down. Okay, with our lesson today, I'd like us to move on to looking at the extrusive features now associated with volcanicity. But from general, maybe from the students generally, I thought that maybe we should spend one more lesson on looking at understanding and getting to really recognize the intrusive features first before we move on to looking at the extrusive features. If time does allow, and if I think that maybe we've covered enough of the intrusive features, then we will move ahead to looking at the extrusive features. But let's go back now and let's look at what you were supposed to have done, and we'll also look at how you have understood differentiating between the different types of intrusive features we looked at in our last lesson. The activities for your homework were to look at the construction of a diagram, and from that diagram you were supposed to show the different intrusive features associated with volcanicity. We looked at the definition to what volcanicity is, and when we are studying volcanicity, we are simply looking at the state of being volcanic, or we are looking at any features associated with volcanoes or volcanicity. The state of being volcanic or pertaining to volcanic activity is the study of what we call volcanicity. So our study saw us looked at the features that are formed as a result of volcanic activities under the surface, and then today we are supposed to look at volcanic activities associated with features that are formed on the surface. From those different intrusive features, you were supposed to also explain each of those, making reference to the diagram that you were supposed to have constructed. Okay, let's look at the diagram now showing those different intrusive features, and I will get volunteers from the class to simply tell maybe the rest of us what you have understood or the definition that you would have understood from the handouts that were distributed in our last lesson. The different intrusive features are, we are looking at Batholith, one of those intrusive features formed as a result of volcanic activities but intrusive. Formation of seals, formation of Lacolith, and formation of dikes. Those were the four features we looked at. If you looked at your readings also, you would have found out a little bit about stock. That is also another intrusive feature. And maybe you should be able, or you might be able to locate where that is from the diagram that you would have constructed. And also another of those features that is not mentioned here on our monitor, but maybe you might have made note of from what I explained in our last lesson, was that of a Alapolith. We have a Lacolith, we have a Alapolith, a seal, Bathylite, and a dike. Your reading does mention a little bit on stock also. From what you have constructed and from what we have looked at in our introduction to intrusive features, I'd like you now to tell me or to give me a definition for each of those different features. From your explanation, it will also tell me that you have understood how to identify or differentiate between those different intrusive features. We will start with Christopher at the back. Any of those features, and briefly explain what you understand about that particular feature. So you have a couple of features to select from. You give us only one, and you also explain what it is.
A seal.
Okay. As shown here by the arrow, this feature here. There's a couple of them from our diagram. 1, 2.
It's when a sheet of magma lies along the bearing plane. It's called a seal. Some seals form ridge-like escarpment when they are exposed to erosion, and others may give rise to waterfalls and rapids where they are crossed by rivers.
Okay, so the important point that is made here is the way in which this feature is actually in terms of how it is formed. And if you look at a seal, it is actually lying horizontally. And it does mention that usually a seal would be found along what we call bedding plane. Later on, when we look at our work on formation of rocks, you will note that sedimentary rocks, when they are formed, usually they are formed from accumulated materials, of which those materials are laid in what we call layered sequence. And the laying down of those materials in layered sequence would give what we call different strata. And according to the diagram here, we have 3 different layers of materials which have been accumulated, which forms 3 strata, different strata that is. When we talk about a bedding plane, we are looking at that boundary which separates one layer of sedimentary rock from the next layer. And for the intrusion of magma along horizontal bedding planes, it is this area here when magma actually intrudes and solidifies to give us the feature which is referred to as a sill. So the sills usually along bedding planes. And those bedding planes simply refer to the boundary which separates one strata from the next strata when sedimentary rocks are actually formed or laid down. So if you look at our diagram, can you see that there are also different layers here under the surface? Okay, and along those black lines that separates one layer from the next, that's where magma intrudes to form the features which are called sill. Okay, thank you for the explanation there. Note, he also mentioned that those features can be exposed to the surface and they can be exposed through the process of erosion. So given time, maybe those features at the top get to be eroded away and then this feature might be exposed on the surface. Thank you. We move on. Rebecca, give us another feature and explain that feature beside the sill now which has been explained.
Dikes. A dike forms when magma squeezes into fractures of the surrounding rock and cools. Dikes may be vertical or inclined. Some dikes, when exposed on the surface, resist erosion and stand up as ridges or escarpments. Oh, sorry, no. Escarpments. Others are easily eroded and form shallow depressions. Like sills, they sometimes give rise to waterfalls or...
Okay, so we're looking at the dikes here. Note, they usually follow cracks or fault lines. And note that the fault lines have to be vertical. And in some readings, it will tell you that those particular cracks, they actually cut through bedding planes. So you note the bedding plane, and if a fault line actually cuts through the bedding plane, that means vertically, it can be straight up, straight down, or it can be inclined. And when the fault line or the cracks cut through the bedding plane and magma intrudes and solidifies along those cracks or fault lines, then the feature which is created is that of a dike. And the simplest maybe way to remembering it is a sill is a horizontal intrusion of magma along a bedding plane. A dike is a vertical intrusion of magma along fault lines or cracks. Again, given time, they could be exposed onto the surface through the process of erosion. We move on. The next feature and explanation.
Lacolith. When viscous magma is injected between layers of sedimentary rocks, it tends to arc up the overlain strata. The resulting intrusive body, a lacolith, is lens-shaped with a flat floor and an arched roof. Lacolith usually occurs in blister-like groups in areas of flat-lying stratus. They can be several kilometers in diameter and thousands of meters thick. Typically, they are porphyritic. Lacoliths occur along the magma of central stalk and appear as an inflated sill. Lacoliths can also be fed through a conduit from below.
Okay, we're looking at maybe a simple explanation from all of that information. It's just like a bubble-like intrusion or a mushroom-like intrusion of magma along a bedding plane. And then what happens here, if magma intrudes along a bedding plane, it might actually cause the overlying strata to actually go up and form a bubble-like feature. And when we have a bubble-like feature or mushroom-like feature intruding along a bedding plane and forming such, then we say that is a Lacolith. What could happen is that on the top or on the surface could also be shaped according to the feature which has intruded under the surface. Okay, a dome-like feature may be created on the top there to follow the shape of the Lacolith. You note that the Lacolith is following a bedding plane, and it is actually forcing the strata to actually rise up in a dome-like feature. When we look at that feature in a diagram form, you can see it looks like a mushroom. Okay, so here with the root of the mushroom coming up and then the feature being created. So we usually give a description to say a mushroom-like or a bubble-like intrusion of magma along the bedding plane. Susan, the next feature.
Batholiths. Batholiths are very large masses of coarsely crystalline rocks, generally of granitic composition. They form almost exclusively in continents and large island arcs and do not occur in oceanic islands. Batholiths are the largest rock bodies in the Earth's crust, and many cover several thousand square kilometers. They typically form in the deeper zones of the mountain belts and are exposed only after considerable uplift and erosion.
Okay, I think with that explanation, that's simple and straightforward for the batholiths. So we're looking at large intrusive features which have been formed. Usually they would form the basis of large mountain ranges, that is. The difference between a batholith and a Lacolith, you can see that the Lacolith sometimes is actually closer to the surface compared to a batholith, which is an intrusive feature formed deep in the Earth's crust. And that could be one of the main differences that you can maybe work out or pick out from a Lacolith and a batholith. Looking at those features, note there's another feature here, which is known as a Alapolith. Would someone like to explain that, even though the information was not given? Just look at the diagram. Will you be able to pick up and work out what the definition might be? You make a comparison between a Lacolith and that feature here, which is known as a Alapolith. Someone would like, maybe by looking at the diagram, to give us what they think the definition might be for this feature. Okay, we look at a Lacolith, mushroom-like feature, dome-like feature. Note that of a Alapolith. It is a basin, yes, a basin-like feature. It's a depressed area along a bedding plane, but instead of forming a dome-like shape, it is now forming a basin-like shape. Can you see that from the intrusion here? Here, the intrusion is actually being forcing the strata up, whereas here, the intrusion is actually forcing the strata down in a basin-like feature. So a Alapolith is simply a basin-like feature which is formed as a result of intrusion of magma along a bedding plane. So maybe you can make note of that with your diagram, and you can also label that feature. Anyone with any queries or questions now with regards to what we have looked at on those different intrusive features? No questions? Okay, I'm going to give you 5 minutes, and only 5 minutes. And in that 5 minutes, for those who have not actually labeled the diagrams and completed the construction of the diagrams, you are given the 5 minutes to do that. And you check your definitions also. For those who have completed their diagrams, check your definitions. your definitions. Get them in because I'm collecting those worksheets back for the other class to use, so make sure you have the information in your exercise book. The Lacolith is not this feature up here. It has to be an intrusive feature, so you have to go under the surface. If it's up here, you'll get it wrong. So put your arrow down. Those are intrusive, so that means under the surface. Again, if you point to a Lacolith out there, you're going to actually get it wrong. You point to the Lacolith as the intrusive feature at the bottom. Yes, it goes all the way down. Yeah. It's the intrusion of magma which is solidifying here and not the top feature. The top feature is a dome which is formed. So we'll have to make corrections to that one. Yeah. Good. Where's your book? Oh, you've got the information completed. Okay, so your definition to Lacolith, a basin-like feature. Okay, make sure that is. See, okay, good. Just talking about the fact that if you label the Lacolith as up here, you would have got it wrong because it's supposed to be an intrusive feature. The bubble-like intrusion causes a dome on the surface. So similar for you. You have to point to that feature there, not at the top. Where is the Lacolith? Yep, good. Do you have a definition to stock? Did you also make note of that? Include it, because that's on the worksheet there. Just maybe read through and see if you can pick up the main points from it. Okay, most of you should have your diagrams completed by now, making sure you also labeled your diagrams accurately. Your definitions must also be in the book, in your exercise book, to state that you know how to differentiate between those different intrusive features. Okay, we're going to move on. That's the 5 minutes that I've given you for the completion of that diagram. I'd like to also make a point here, since a lot of students are putting out the information here for the Lacolith. On our diagram here, it is actually pointing to this feature out there. Note that these features that we've looked at on a Batholith, a seal, dike, a Lacolith, a Alapolith, and perhaps a stock, all of those are intrusive features. So when it comes to plotting those features, make sure that your arrow is actually pointing to the intrusive feature. If you just point out here, then that would be wrong, because this feature out here is a dome, and the dome is actually an extrusive feature created as a result of the intrusion of magma under the surface. So you get your arrow pointing straight to the feature, which is the intrusive feature. Don't just leave it up there at the top. So you check your diagrams and ensure you are pointing or labeling those features accurately. We'll move on. Okay, note now, with all of those features and the diagrams, we check now on our definitions. Some of you did not get your definitions down. We look at the information from the monitor, and you can double check. Again, with those students who have given the answers on the explanation, we can double check with this information. We start off with the first of those features, the Lacolith. Note a mass of igneous rocks intruded along the bedding planes of sedimentary rocks, like a seal, but swelling out to form a bubble-like or a mushroom-like feature. So you see the intrusion of magma along a bedding plane will give us a seal. But if there is a bubble-like intrusion or a mushroom-like intrusion, then that feature becomes a Lacolith. The upper surface may also swell out in the shape of a Lacolith, causing a dome-like feature above. So when we are plotting our information, note, we do not plot the Lacolith as an extrusive feature. It is an intrusive feature. Get your arrows to point to the intrusive feature. Okay, we can see maybe a photograph now showing us an example of a Lacolith in reality. And here you have a Lacolith in the southern San Andreas Mountains. We have already looked at the San Andreas Fault, and along that region, you also have the southern San Andreas Mountains on the foreground, exhibiting fluid escape features, and the floor of the intrusion is visible in the photograph. So we're looking at this feature here. It's an example of a Lacolith exposed in the St. Andreas Mountains. Okay, so in reality, we're looking at an example here. A Lacolith on its own, note, a dome mountain forms when rock layers are actually pushed up by a Lacolith, similar to what is shown here. So here we're looking at that feature on its own now, not with the other features. Okay, we move on. The next feature that we've looked at is that of a Bathylite. We'll check the definition. This is a very large mass of magma which often forms the root of a mountain. It is made of granite and can become exposed on the surface by the removal of the overlying rocks by erosion. Again, we're looking at granite, and granite are rocks which are formed as a result of volcanic activities, but they are plutonic intrusive rocks, which comes under the grouping of igneous rocks. Here we have a photograph now to show a Bathylite in reality. Note that the surface of the huge Bathylite of the Sierra Nevada in California formed as intrusive volcanic rock, and it is 640 kilometers long. So we're only looking at the surface of that. We are not looking at what is actually below, because the top part has been actually eroded, and the surface is actually shown here of a Bathylite, which is about 640 kilometers long. Remember, I mentioned in our previous lesson that some of those features, you do not expect to see all of those features formed together like the diagram that we constructed. For convenience sake, we are putting them together so that we can see what they are when we are comparing. Most of them would occur in isolation, one and then the next one on its own, and it can depend on how far magma has actually intruded to form those features. For the case of this one here, we're looking at about 640 kilometers long. Okay, note the Bathylite itself again. The rocks surrounding the Bathylite are changed to metamorphic blocks by heat and pressure, and the exposure of the Bathylite can be as a result of the erosion of the overlying rocks, and that's when this particular feature can be exposed on the surface. Like in the case of here, we are looking at that feature on the surface, and that can only occur as a result of erosion of the overlying rocks. The next feature is that of a seal. We'll check the definition. Already as explained by the student who gave the definition, when a sheet of magma lies along the bedding plane, it is called a seal. I've already explained to you what a bedding plane is. A bedding plane is simply the boundary that separates one strata of rock from the next. This is usually associated with the sedimentary rocks. Some seals, they form ridge-like escarpment when exposed by erosion. And an example given there is the Great Wind Seal in northern England. And other seals may give rise to waterfalls and rapids where they are crossed by rivers. We look at a photograph showing us an example of a seal in reality. It states there that you have a volcanic seal which is exposed on the valley walls in Yellowstone National Park, United States. You can see that here. So that's a photograph or diagram showing an example of a seal in reality. Okay, again, that feature can only be exposed through erosion or perhaps tectonic plate movements where the land is actually forced to come up onto the surface. Okay, so those are the features we've looked at. Note, we did not give a definition to what a stock is. You have a definition from the handout that was distributed. You can make note of it also into your exercise book. The next feature is that of a dike. When a mass of magma cuts across the bedding planes and forms a wall-like feature, it is called a dike. I've illustrated with a simple diagram here. When we talk about cutting across a bedding plane, you note it is going to be a vertical fault or crack where it cuts the bedding plane. Dikes may be vertical or they may be inclined. And some dikes, when exposed on the surface, they resist erosion and stand up as ridges or escarpments. And others are easily eroded and form shallow depressions. Those ones that actually are exposed on the surface and they resist erosion, that's because they are hard rocks. Therefore, they do not erode quickly. So we look at an example here of a volcanic dike exposed in a road cutting southern New South Wales in Australia. So here, along the road cutting, you can see an example of a volcanic dike. See another example, the volcanic dike called the bread knife. In Warrumbungles, that's in the National Park in New South Wales, Australia, it stands high above its surroundings as the softer rocks on either side have been actually eroded away. So this is an example of a dike. Remember, it's a vertical intrusion. All the other rocks have been eroded away, and because it's hard rock, it has not been eroded away and it's still standing there. Called a bread knife in the National Park in New South Wales. Okay, so here's an example of the feature in reality. And again, we have the diagram there showing all those different features that we have looked at. Okay, I think that will also bring us to the end of our lesson, and we will look at the information on volcanoes, this time coming to extrusive features in our next lesson, and that will be tomorrow. Okay, class, if you can stand up now. To the pilot teachers, our keyword for today is volcano. That's for lesson 35. Good afternoon and thank you, students.